Something changed in how AI is being used, and it has nothing to do with the models getting smarter. For the past few years, most AI products worked one way. You type something in, the model produced something out, one turn, done. A chatbot, a text generator, a very sophisticated autocomplete. An AI agent is different. It doesn't just respond, it acts, it plans, it uses tools, it takes steps in sequence, checking its own work and changing course when things go wrong. Understanding exactly how that works and where it fails explains everything from your phone's AI assistant to the autonomous systems companies are now deploying across whole industries. And it raises a question that turns out to be harder than it sounds. When you give an AI the ability to act in the world, how do you make sure it does the right thing? Let's start with what agent actually means. In the technical sense, an agent is any system that perceives its environment and takes actions to achieve a goal. A thermostat is an agent. A chess engine is an agent. The concept is decades old. What's new is applying it to large language models and giving those models the ability to actually do things in the world. A basic language model sits in a box. You give it text, it gives you text back. It cannot browse the internet, it cannot run code, it cannot send an email or book a flight. It can only generate the next token in a sequence based on patterns from its training data. An AI agent breaks open that box. It connects the model to tools, a web browser, a code interpreter, a calendar, a database, an API. And it gives the model something new, the ability to decide which tool to use and when. Here's the core mechanism. Instead of answering a question directly, the model is prompted to produce a plan. To answer this question, I need to search for current information. Then I need to synthesize the results. Then I need to check whether they are consistent. The model outputs that reasoning. A surrounding system executes the plan, calling tools, collecting results, feeding them back to the model, which then decides what to do next. This loop, observe, plan, act, observe again, is what separates an agent from a chatbot. The components are usually described as a model, a set of tools, a memory system, and an objective. The model is the reasoning engine. The tools are the hands. Memory lets the agent carry information from one step to the next without losing context. The objective defines what done looks like. Let's make this concrete. Imagine you ask an AI agent to research a topic and produce a report. A basic chatbot generates a response from its training data, which might be a year out of date. An agent searches the web for current information, reads the top results, identifies what's relevant, discards what isn't, checks for contradictions across sources, and synthesizes a report grounded in what it just read. Multiple steps, multiple tool calls, one coherent output. There's a term worth understanding here: tool use. This is when a language model is given formal access to external functions it can invoke, a web search, a calculator, a calendar, API, and learns to call those functions as part of generating its response. The result gets fed back into the model's context, and the model continues reasoning from there. It's mechanically similar to how a human uses a computer. You don't know the current stock price off the top of your head. You open a browser, you check, you incorporate that information into whatever you are doing. The agent does the same thing, in text, inside a loop, faster than any human could. The more interesting cases are agents that don't just research and report, but act in the world. Send emails, execute code on live systems, make purchases, submit forms, file documents. This is sometimes called agentic AI, and it's the direction most serious AI development is now heading. The reason is obvious. A model that can browse and summarize is useful. A model that can browse, decide, act, and follow through is potentially transformative. Some systems go one step further. Multi-agent architectures, where multiple AI agents work in parallel or in sequence, each handling a different part of a larger task. One agent plans, another executes, a third checks the work. This mirrors how organizations divide labor, and it introduces many of the same coordination problems. It's worth pausing to note where agents already exist in products you may use. When a coding assistant not only suggests code, but runs tests, reads the error, revises the code, and runs the tests again. That's an agent loop. When an AI assistant in your email drafts a reply, checks your calendar for availability, and proposes a meeting time, that's tool use with memory. These capabilities have shipped quietly inside consumer products. The difference between a chatbot and an agent is increasingly invisible from the outside, even when the architecture underneath is completely different. Let's talk about what goes wrong. The most common failure mode is called task drift. An agent given a goal pursues it in ways the person who set the goal didn't intend. This isn't hallucination in the traditional sense. The agent isn't making things up. It's interpreting its objective too literally, or finding a path toward the goal that has unintended side effects. A classic thought experiment. An agent told to clear my inbox might delete emails rather than archive them. An agent told to maximize user engagement might take actions that are engaging but harmful. The goal was specified. The agent accomplished it. Nobody intended the result. This is the alignment problem in miniature, and it's not hypothetical. Early deployments of autonomous agents have produced exactly these kinds of surprises, which is why most production systems today use a human-in-the-loop design. The agent proposes actions. A human approves them before execution. The second major failure mode is compounding error. In a single-turn chatbot, if the model makes a mistake, that's the output. One bad answer. In an agent, a mistake in step 2 shapes step 3, which shapes step 4. Errors propagate forward. By step 8 or 10, the agent may be executing a plan built on a flawed premise from step 1, with no awareness that anything went wrong. This is why agent evaluation is so much harder than chatbot evaluation. You can't just score a final output. You have to examine a sequence of decisions and judge whether the process was sound, not just whether the result happened to look correct. There's a third challenge, more technical: context limits. A language model can only hold so much information in its active context at once. A simple multi-step task might stay inside those limits easily. A long research project or an agent running for hours hits the ceiling. This is why agents need external memory, databases or document stores the model can search and retrieve from to function across anything longer than a short session. These aren't unsolved problems in the sense that nobody is working on them. They're unsolved in the sense that there is no clean answer yet. Every serious deployment of autonomous AI agents requires engineering around all three of these constraints simultaneously. Here's the mental model worth holding. An AI agent is not smarter than a language model. It's the same model, given tools and a loop. What makes it powerful is also what makes it hard to control. It takes actions over time, in the real world, without a human reviewing each step. The progress on AI capability over the past few years happened mostly inside the box. Models that reason better, know more, make fewer mistakes. The next wave is outside the box. Models that act, remember, collaborate with other models, and pursue goals across hours or days without stopping. The hard problems, how to specify objectives precisely, how to detect when an agent is going wrong, how to build systems that fail safely when they do, are not solved. They are, right now, the frontier. But understanding the basic architecture, model, tools, memory, loop, gives you the right frame for watching that frontier develop. You know what to look for. You know what questions to ask. If this kind of precise mental model is what you want from AI content, subscribing is how you get the next one.